The last physical property of ionic substances that we are going to explore is that ionic substances tend to be soluble in water. So, ionic substances can dissolve in water. This is the H2O molecule, and this figure shows the electrical distortion in a water molecule. Why is there electrical distortion? Well, H2O is a covalent molecule, but there is a slight negative charge on the oxygen atom and a slight positive charge on the hydrogen atom. When this exists, when there is a slight negative and slight positive charges, it creates an electrical distortion in the molecule, and therefore we call water a polar molecule. Water is described as a polar molecule because of its slight positive and negative poles. This figure shows how water molecules, which we now know are polar, pull the crystal apart. This is sodium chloride crystal put in water. The water molecule, H2O, is polar, so it has a slight positive and slight negative poles. The slight positive hydrogen accumulates around the chloride ion Cl-, which has a negative charge. And also, Cl- is attracted to this slight positive hydrogen ions. This causes sodium and chloride ions that make up NaCl, sodium chloride, to be separated by water, and therefore the crystal is broken down and dissolves in water. This is exactly what happens when you add salt to water. Note that NaCl is soluble in water while magnesium chloride is not. Why is MgO insoluble in water? This is because the forces between magnesium ion and oxygen ion are strong, so water can't break those strong bonds, unlike the case in sodium chloride, NaCl.